what does it mean, the composite function? So let's say f of x is equal to x in the cube, okay? And g of x is equal to, or let's say h. G of x is equal to the x in the power of 4. Okay? So let's say f of x is h multiplied to the g. What is this? So this will be x in the power of 3 multiplied to the x in the power of 4, right? Or let me calculate this with let me give you a small example with the numbers. So 2 in the power of 3 multiplied to the 2 in the power of 4. What is this? 2 in the power of 7, right? So this will be equal to the x in the power of 7. Okay? Because there is a rule. X in the power of n multiplied to the x in the power of m, it is equal to the x in the power of n plus m. Right? What is x in the power of n in the power of m? X in the power of n multiplied to the m. Right? Okay? So, the composite function, the composite of the two functions h and g is when you substitute this x here with the g. Okay? So this will be equal to the h of g of x. Okay? This is what does it mean. So if h of x is x cubed, what will be the h of g of x? It will be g of x in the cube. Right? So what is the g of x? It's x in the power of 4, right? This will be x in the power of 4 in the cube. This will be x in the power of 12. Okay? So taking the composite between h and g is different than just multiplying them. Okay? So this is different. So let's do a couple of more examples, okay? Because finding the composite function is easy. But if I give you the result and I tell you, okay, so tell me two functions whose composite will be equal to this function, then this is difficult. You know what I mean? Okay, if I say, okay, so x cubed is the first function, x in the power of 4 is the second function. What is their composite? It's x in the power of 12. Okay, so later on we'll consider the examples where I will ask you, hey, here is x in the power of 12. Tell me two functions whose composite is equal to the x in the power of 12. Okay, so like inverse questions. Okay, so that is why we need to do a couple of examples first. Then first of all, then we'll start this topic. Okay, so let's say h of x is equal to the sine of x. G of x is equal to the x squared. What is the composite of the h and g? So instead of this x here, we need to substitute the g of x, right? So it will be sine of g of x, right? Then if you substitute the g of x with the x squared, it will be sine of x squared, right? Okay, so this is equal to the h of g of x, and this is equal to the sine of g of x, and this is equal to the sine of x squared. Okay? So what will be the composition of the g and h? Is it the same as this one? No. No, right? Because now we need to substitute this x of the g with the h of x, right? So this will be equal to the g of h of x, g of h of x. So it will be h of x in the square, and this is equal to the sine of x in the square. Okay? It gives you different results. More examples? Okay. So let's say h of x is 1 over x from the cubic root. Okay? And g of x is x squared plus 3x plus 5. What is the h composite circle g? So this is called circle or composite circle. The reason why we're continuing this because yesterday, and it was another group, we finished everything. Right? So you have to be in the same phase. There should not be phase shift, right? Do you remember what was the phase shift? Why are you looking like this? Okay, are you doing this? What? 1?
No, 1 over.
Okay. So this is actually equal to the h of g of x, right? So if h of x is equal to the 1 over cubic root of x, then h of g of x, it will be 1 over cubic root of the g of x, right? So now we have to substitute the g of x with this function, x squared plus 3x plus 5 from the cubic root. Okay? So you will need to do a couple of exercises, then there will be also the online quiz on this topic. You have to do this. Okay? Now let's talk about the chain rule. Do you remember what was the chain rule? Right? So it is when we would like to take the derivative of the composite functions, right? If my function is previously sine of x, and another function is simply x squared, we can find the derivatives separately easily, right? So what is the derivative of the h? It's simply cosine. And what is the derivative of the g? It's simply tx, right? Now, the problem is I would like to find the derivative of their composite. Okay, so let's say, first of all, I would like to find the composite. So let's say the new function f of x is the composition of the g of x and h of x. What is the derivative of the x? Okay, so in order to find its derivative, we need to use the chain rule. Okay, so the chain rule tells you, hey, if you would like to take the composite of the two functions, so which can be written as g of h of x, right? You can write this down as g prime of h of x multiplied to the h prime of x. Okay, this is what does it mean. So what you need to do is, you need to find the derivative of the g first in terms of the x, okay? Then you have to substitute x with the h of x, okay? Then multiply this as the derivative of the h. So today we will do a couple of examples. So we will not do the proof of the chain rule, but we can explain this like an intuitive proof of this. So do you remember previously we say that delta f over delta x is the average change of the function, right? When you take its limit, it gives you the instant change of this function, right? And we denoted this as df over dx. Right? Now let's try to write down the derivative of the composite function in terms of the Leibniz notation. Okay? Leibniz notation, do you remember? So I told you before that this notation was introduced by Leibniz, right? So we're going to write down the derivative of this composite function in terms of the Leibniz notation. Okay? So I would like to find what is the derivative of the f of g of x with respect to the x. Right? I can write as df dx. Right? Okay. So it appears according to the chain rule, it is equal to the df of g of x with respect to the g of x multiplied to the dg of x over dx. Oops. So something is wrong here, right? So just the notation, okay. Notation. Sorry. So if g of h of x, right? It was different notation. dg of x, it is dg of h of x over dh of x multiplied to the dh of x over dx. Okay? Now look at the two formulas and verify that they are the same. Okay? Do you remember? F prime was simply df over dx. Right? F prime is df over dx. So here, you would like to find this f prime, right? Basically, g of h of x prime with respect to the x, right? It will be dg over dx, okay? So separately, their meaning is different, but when you take the ratio, it means that this is the derivative, okay? You know what I mean? So separately, the meaning of the df and dx are different. But when you take the ratio df over dx, it means that this is the derivative of the function f with respect to the x. Okay? So now I need to find the derivative of this function with respect to the x, right? In terms of the Leibniz notation, this is dg over dx, right? Derivative of the g with respect to the x, right? This was derivative of the f with respect to the x. This is derivative of the g with respect to the x, right? This is equal to the dg over dh, derivative of the function g with respect to the h, multiplied to the dh dx, derivative of the h with respect to the x, right? Now look at this formula, right? So in this formula, I need to find the derivative of the g with respect to the h of x, right? Then multiply this to the derivative of the h with respect to the x. Do you see that this is equal to this one, and this corresponds to this one, and this corresponds to this one, right? Okay, so here we say that I would like to get some intuitive feeling that the chain rule is correct, right? So if I consider these two ratios not as one like a ratio, but like a simple ratios, then theoretically I could just delete this one and this one, right? Then the left hand side will be equal to the right hand side, right? So this is kind of intuitive proof of the chain rule. Okay? Do you understand that this corresponds to this one? Yes? dg over dh means the derivative of the g with respect to the h. dh over dx means derivative of the f, h with respect to the x. Okay? So if you can delete them, right, because we can do this, what is 3 over 2 multiplied to the 2 over 5? 3 over 5, right? You can delete this 2. Okay. Let's do a couple of examples, okay? Then you can go. So let's say I would like to find the derivative of the h f of x, which is sine of x squared. Okay? Before we apply the chain rule, we first of all need to write down this function as the composite of the two other. Okay? Okay? So I would like to ask you, first of all, write down the f of x as the composite of the h of x and g of x. Basically, h of g of x. Okay? Then, in the second step, find the derivative of the h, find the derivative of the g, then find the derivative of the f of x by multiplying the h prime of g of x multiplied to the g prime of x. Okay? At every step, in every example for the chain rule, we have to do this thing. Okay? So let's start with the first step. So what do you think? What kind of two functions I need to choose so that their composite gives me sine of x squared?
Sine of x and x.
Sine of x and x squared, right? Okay. So h of x is equal to the sine of x, and g of x is equal to the x squared. Okay? Let's verify this. So I need to find h of g of x, right, is equal to the sine of g of x. Right? If you substitute the x with the g of x in the left hand side, we have to do the same thing in the right hand side, right? So this will be equal to the sine of x squared. Right? Okay? So which is correct, right? So which is our function. So in the second step, I need to find the derivative of the h. What is this? Cosine of x. I need to find the derivative of the g of x. What is this? 2x, right? Then I can find the derivative of the f of x by substituting this x with the g of x, okay? So the h prime of not just the x, but g of x, okay? Multiplied to the g prime of x, okay? So if h of h prime of x is the cosine of x, what is the h prime of g of x? It's cosine of g of x, right? Cosine of g of x. Do you understand this? If h prime of x is simply cosine of x, then h prime of g of x is cosine of g of x, right? And multiplied to the g prime of x, this is equal to the cosine of x squared multiplied to the tx. Okay? Let's do a couple of examples. For every example, you have to do the step. 2 steps. X cubed minus 1 in a power of 100. So first step, you have to write down this function as the composite of the h of x and g of x. Basically, h of g of x should be equal to the f of x. In the second step, find the derivative of the h. Find the derivative of the g, and find the derivative of the f is h prime of g of x multiplied to the g prime of x. Okay? If you know how to do this more faster, do not do this. I don't accept this answer. You have to do this step by step. The first step and the second step. First step, find the two composite functions. Second step, find their derivatives and write down this like this. So, kind of like an outer function. What is the outer function? What looks like an outer function? It should be something in the power of 100. Something in the power of 100, right? So g in the power of 100, right? So this is what x in the power of 100, right? So if you take the h of x as the x in the power of 100, and if you substitute the x with the g, it will be g in the power of 100, right? Something in the power of 100. Then you can take the g as x cubed minus 1. Okay? So the first step is we take h as x cubed, right? Because if you put the h of g of x, it will be g of x in the power of cube. 100. Right? And then I need to take the g of x as x cubed minus 1, right? Now if I substitute this as the h of x, it will be x cubed minus 1 in the power of 100, right? So the next step is I need to find the derivative of the h, which will be 100 multiplied as the x in the power of 99, right? Then I need to find the derivative of the g of x, it will be 3x, right? Now I need to find the derivative of the f prime of x. It will be h prime of g of x multiplied to the g prime of x, right? So since h prime of x is what? 3x squared. Sorry, yes. Okay, so if h prime of x is equal to the 100h in the power of 99, then h prime of g of x, it will be 100 g of x in the power of 99, right? Multiplied to the derivative of the g of x is 3x squared, so it will be 100 3x squared minus, x cubed minus 1 in the power of 99 multiplied to the 3x squared. Okay? So I know that you can do this faster, but in the first stages, we're going to use the chain rule by doing these two steps, okay? So you have to tell me what are the two composite functions, find their derivatives, then use this formula in order to find the derivative of the composite function. Okay? Thank you very much. See you next week.